Lesson 4.4, Equations with Variables on Both Sides. Sometimes equations have variables on both sides, and we saw this back in Module 3 when we simplified each side of an equation. Today we're going to be taking that a step further, and in order to solve an equation we must isolate the variable. So we need the variable by itself on one side, and a number by itself on the other side. Then we know we're solved. Following specific steps will isolate that variable so that we can solve the equation. The first thing we need to do is make sure that each side of the equation is simplified as much as possible before we start moving things from one side to the other. After simplifying each side, then we use inverse operations to solve the equation. So here's our first example. Check to see if each side of the equation needs to be simplified. That's the first step. So I look and I have 8x minus 4. These can't be combined. Nothing can be done to them. And here I have 5x minus 14. Again, I can't do anything with these. They're already as simplified as they can be. Step 2 is I relocate the variables to the same side of the equation. And I have two methods. Method 1, or A, is to pick up and move to the other side and change the sign. And method B is to add or subtract from each side. So what I can do is I can pick this 5x up and I can move it over here. If I do that, I change the sign. Anytime you change sides, you change signs. So this becomes 8x minus 5x minus 4 is equal to negative 14. 8x minus 5x is 3x. So I have 3x minus 4 is equal to negative 14. The other step is I can actually add or subtract, because at a positive 5x I would subtract it. And the reason I do that is because these will cancel. 5x minus 5x is 0. And then I have 8x minus 5x is 3x. Bring this down and bring this down. So as you can see, they both result in the same answer. I just want to make sure that you have multiple methods to try. After I've moved the variables, I combine to simplify. That's what I did on this step here, on this row. Then I relocate the constant, which again I can pick up and move, or I can add or subtract. So if I pick it up and move it, I'm going to pick this up, and over here I'll have 3x is equal to negative 14 plus 4. Or I can add 4 to both sides, like that. In either situation, I will get 3x is equal to negative 10. Finally, I will multiply or divide to solve for x. And this will be the same on both. And they both result in the same answer. X is equal to negative 10 thirds. Okay, so I have 4 more examples. And each of these, if we look, is simplified already on either side. I can't combine any of these terms. So here I have 3x plus 10 is equal to 9x minus 32. I'm going to go ahead and subtract 9x from both sides, so I'll use method B on this one. And I have negative 6x plus 10 is equal to negative 32. Then I'll subtract 10 from both sides, and I have negative 6x is equal to negative 42. Because they're both negative. I'll divide both sides by negative 6, and that will give me that x is equal to 7. Now on this one, I'm going to do method A, where I'm going to pick it up and I'm going to move it over, and I'll have 8x minus 32x plus 5 is equal to negative 7. 8 minus 32 is negative 24. Then I'll subtract 5 from both sides, and I have negative 24x is equal to negative 12. Divide both sides by negative 24, and I get that x is equal to 1/2. Using subtraction again. 11 minus 8 is 3x, minus 19 is negative 10. Add 19 to both sides. Gives me 3x is equal to 9. Divide by 3, and x is equal to 3. If I subtract 8x from both sides, I get 2x plus 5 is equal to 5. Subtract 5, and I get 2x is equal to 0. I can divide 0. 0 on top is okay. I just can't have 0 in the denominator. Anything, 0 divided by any number is equal to 0.